Alright, so in this video I'm going to go through two more of the modeling, those box problems, surface area, finding the mins, maxes, that I did not go over during class. So I'm on page 32. I thought it was page 31, but I guess it's 32, number 8 and number 9. Okay. So for number 8, open box with a square base is required to have a volume of 200 cubic feet. Then I know that here's my box. It's an open box, square base. So I know this is x, and this could be the height, h. So I know that the volume of this is equal to x squared times h. And then, let's see here, let me draw in also kind of the rest of the box. There you go. So you should be able to see that there are other surfaces. This is also h. Back there, that dotted line is h. The base all the way around is x. So the surface area should equal 4 of the x by h's, because the base is the only thing that's different, but all 4 of the sides are x by h. And then we just need then the x squared for the base. I can use my volume and I can solve it for h, because that's the easiest thing to solve for. So if I divide both sides by x squared, then I get h is equal to v divided by x squared. And I know my volume. My volume is 200. So I can plug that in there. So then for my surface area, I'm going to replace h with 200 over x squared. And for that, you can just put that in the calculator, or you could simplify it to 800 over x plus x squared. So that's what I'm going to put into y1. So 800 divided by x plus x squared. And I'm going to try zoom 6. I'm seeing the left-hand side. And then I'm going to try zoom 0. And there we go. Still not great, so I'm going to go into that window, and I'm going to change that x. Well, first of all, I'm going to change the x min to 0. And the x max, let's try 25. And I always tend to do like negative 100 for y min. And you can start to see how it's increasing, and you should see the minimum point there. All right, so my window, 0, 25, negative 100, and 3760 basically. Forgot what I just said that was. 3760. Okay, so then I'm going to do what is the domain of the problem situation? Well, looks like x is greater than 0 because it kept going on beyond 25 for my x max. And then what value of x, the length of the side, makes the surface area the smallest? So this is where I'm going to find the minimum. So I'm going to do second trace min. So see, I can't see my cursor real well. I'll get it up there above the words left bound. There we go. Enter. And then I'm going to get it to the right. This is annoying, sorry. So my minimum is 7.368 with a surface area, what that will be minimized to 162.865. So my coordinate for the min was 7.368, comma 162.865. So find the value of x that makes the surface area. So this is x, and this is the minimum surface area. So the answer would be x is equal to, I'm using approximately equal to 7.368, and this would be feet. And that's that. For example 9, you've been asked to design an open 2,000 cubic centimeter oil can shaped like a right circular cylinder. So there's my circular cylinder. There's my height. Write a function for the surface area. Well, I know the volume is equal to pi r squared h, and I may need that, so I'm going to start with that. So 2,000 equals pi r squared h. And then I'm going to solve for h, so I get h is equal to 2,000 divided by pi r squared. So for the surface area, remember we talked about unraveling this. I need to use the circumference to unravel, so I need 2 pi r for the surface area for the bottom. If you think about a cylinder and you unravel it, it's really just a rectangle. So I need the length times the width. And one of them is the height. Okay, so surface area is the height, that one for sure. But then to figure out that width, that unraveled is really just the circumference of the circle. So it's times 2 pi r. So, and it says, you've been asked to design an open, okay, so that's why it's just one of them, the bottom. And then we need the surface, that's the area, that's the surface area for the sides. Now I need the surface area of the bottom of the drum, which is just the area of a circle, so that's pi r squared. So now I'm going to replace h with 2,000 divided by pi r squared. And when we do that, the r and the r squared cancel, the pi's cancel. So we get surface areas equal to 4,000 divided by r plus pi r squared. So what is the domain of this problem? Again, I think it's going to be r is greater than 0, but let's go to our calculator. So clearing out that one, I'm going to do 4,000 divided by x plus pi x squared. And I'm going to go back to Zoom 6. And I see nothing, so then I'm going to go to Zoom Fit, Zoom 0. Okay, and I get a better picture there. So I'm going to again go in and change that x max to 25 and the x min to 0. And the y min to like negative 500. That's a big number they have there for that. They have 18,000 for that y max, so maybe I'll make it negative 5,000. And then I think that's decent because then I can see that it's increasing. I see a little bit of an increase. So we'll go to graph. So I just need to see that it's got, I can find the minimum. So then I'm going to go back here for a second and write down what my window was. 0, 25, negative 5,000, 1880. Okay. I'm going to say the domain is x is greater than 0 again. And let's try second trace min again. Bring that cursor over. Oops. Let's try it again. Okay. Good. I didn't get to the right. Okay, there we go. So my minimum is 8.6025 with and the surface area that would minimize that. What's the minimum surface area? Would be 697.468. So 8.60 to the nearest thousandth and 697.468. What is the radius? So x was representing the radius, and this was our minimum surface area. So it just asks for the radius. So the radius r would be 8.603. So you can hopefully see how there's some similarities there. All right, that was it. Happy studying.